This video is to help you find the determinant of a 4x4 matrix. We have the matrix in example 7, and you'll notice that next to matrix A, I've drawn the same checkerboard pattern. We extended a little bit farther now because this is a 4x4 matrix. And so in the explanation, when they compute the determinant of A, they're expanding along the first row, 2, 3, -2, and -5. But they write 2 times the determinant of a 3x3 matrix minus 3 because of this negative sign right here, minus 2 because it's plus -2, and then the last thing in the row is a -5, but because of that minus, they're going to end up writing minus -5, which will become plus 5. And notice that in each case, we multiply those numbers by the determinant of a 3x3 matrix. So I'm going to go ahead and show you example 7 done a little differently. I guess we're looking for an answer of 57. But I'm going to be more selective about which row or column I choose. So let me go ahead and do that with you. As I look at this, and I will get my red pen out, I guess, I'm noticing that row 2 is especially nice. It has a couple of zeros in it. So what I get is I get that the determinant of A is equal to 0 times the determinant of a 3x3 matrix. Now after that, I have a plus sign right here. So plus 1 times the determinant of a 3x3 matrix, and then minus -2 times the determinant of a 3x3 matrix, plus 0 times the determinant of a 3x3 matrix. So really, I'm only going to have to do the determinant of 2 matrices here, right? So when you're looking at the 1, if I cross out the elements in that row and column with the 1 in it, I guess what I'm left with are the following elements: 2, -2, and -5. And I'm left with a 1 and a 0 and a -1. And I'm left with a 2, a 1, and a 1, right? So we're going to need to compute that determinant. And now we also need to compute the determinant of what? Well, here, let me get a different colored pen. Let me get black. And when I'm looking at the -2, if I cross out that row and column, I guess what I'm left with is 2, 3, -5. And I'll skip row 2. And I have 1, 3, and -1. And I have 2, 0, and +1, right? So those are the submatrices that I have. Okay, so what does the determinant of A equal? Well, I need the determinant of this 2x2 matrix. And again, our 3x3 matrix. I think I will expand along the second row again. Why not? I need to remember my checkerboard pattern. So this is going to equal -1 times the determinant of -2, -5, +1, +1. And then let's see, I have a negative sign in the checkerboard pattern. I have a -1, and what would be the 2x2 matrix that goes with that -1? Well, again, cross out that row and column and you get 2, -2, 2, and 1. Okay, so that's what we have so far. I think I'll switch to blue, and I'll write +2 instead of -2. And I guess for computing this determinant, I'll use row 3 here because there's a 0 there. So it's going to be, let's see. So I have 2 times what? Well, so I have +2 from this coefficient. Then I have 2 times the determinant of, it would be 3, -5, 3, -1. Again, these are pluses because of the checkerboard pattern. So I don't have a 0 there, so I don't need to worry about that. But I'll put plus 1 times the determinant of what matrix? Well, with that 1 goes these numbers, 2, 3, 1, and 3. So we are really getting somewhere now, I think. Let me switch back to red and try and finish the problem. I have -1 times, this would be -2 minus -5, okay? Then I have plus from the plus 1. This would be 2 times 1 is 2 minus -4, okay? And then here I have plus, well, maybe I'll distribute the 2, and if I do, I get 4 times what? -3 minus -15 plus, and because I distributed the 2, I get 2 times, and here I have 6 minus 3. Okay, do I have enough room here? Maybe if I scroll down a little bit, I have a little more room to write. Let's try to finish. So let's see. I have -1 times, -2 plus 5 is 3, plus 2 plus 4 is 6. And here I have plus 4 times, now -3 plus 15 is +12. And then I have plus 2 times, that would be 3, 6 minus 3. So let's see what I have. I have a bunch of positive numbers. 6 and 48 is 54. 60 minus 3, I'm getting 57. Is that what we got here? Yes, exactly the same as we got in the book. So I think we're doing okay, and I hope that this video helps you understand how to find the determinant of larger matrices. As you can see, this recursive definition is quite cumbersome. It's good to look for things like zeros, that's for sure.